Welcome back to our videos. Today we will be having a two-part video where we will be focusing on the binomial expansion and on finding the nth term of an expanded form. As we remember, binomials are expressions having two terms, a plus or minus b, and that we use FOIL method in squared binomials. But what if the binomial is raised to a number bigger than 2? That's what we're going to talk about here, together with determining or knowing the value of a, b, and n, and illustrate Pascal's triangle in the expansion. So let's start with having the basic examples. Here we have a plus b cubed. So the first thing we need to do is to expand this into three parts. So a plus b times a plus b times a plus b. So first we need to solve these two. So a times a will be a squared plus a times b will be ab plus b times a plus b times b, so b squared. That can be translated into a squared plus 2ab, since these two have the same variables, plus b squared. That will then be multiplied to a plus b. So a squared times a will be a cube plus a squared times b become a squared b plus 2ab times a will be 2a squared b plus 2ab times b will be 2a b squared plus b squared times a will be ab squared. B squared times b squared will become b cubed. So simplify a cube, a squared b, 1a squared b plus 2a squared b will be 3a squared b. Same with this, 2 plus 1 be 3 ab squared plus b cube. That took quite a lot of our time, but here's another way on this, a much easier way I think. At this moment, the Pascal's triangle joins in. So just a quick trivia about this. The triangle is not really Pascal's. Chinese, Indian, Iranian, German, and Italian mathematicians who came before him studied this triangle array of the binomial coefficients. So this is the triangle. As we can see, the ones are moved sideways and those in the middle are added. So as we can see, we have here 1. We put that on the sides. 1 plus 1 will be 2. Put the 1 here. 2 plus 1 will be 3. Same with this side. 3 plus 3 will be 6, and so on and so forth. Our number of terms will also be affected by this. So for example, we have here 3. So we have 4 terms, right? 1, 3, 3, and 1. Now, how can this be used in the expansion of our binomials? We have here the Binomial Theorem, where it states that if an n is the set of all real integer and a and b is the set of all real numbers, then a plus b raised to n will be equal to the summation of I to n, or ni, that will become a raised to n minus I times b raised to I. So as for a visual about this, let's go back to our example. A plus b cube. So we have here, we will follow this. So a plus b raised to 3 will be equal to sigma notation 0 to our n is 3. 3, 0. Then our a will become n, which is 3 minus 0, and b I plus a. Our next term will be 3 minus 1, b1. The next will be a 3 minus 2, b2 plus a raised to 3 minus 3, b3. So we'll rewrite this. So a 3 minus 0, b raised to 0, plus a raised to 3 minus 1, b raised to 1, plus a 3 raised to 3 minus 2 times b squared, plus a raised to 3 minus 3, b cubed. So 3 minus 0 will be 3. We'll have 3, and since b 0 will be, that will be 1. 3 minus 1 will be 2, so this will be a squared b, plus 3 minus 2 will be 1, so this will be a b squared, plus 3 minus 3 will be 0, so that's why it will become 1 b cubed. Then our variable on the that's how we will have our variables. About their our coefficients, let's go back to our triangle. So we have here the 3, so we'll start 1, 2, and 3. So the variables, the coefficients will become 1, 3, 3, and 1. So 1 times 1 will be 1, 1a cubed, plus 3, there are no other coefficients, 3a squared b, plus, same with this, 3ab squared, plus 1 times 1 will be 1, b cubed. So as we can see, we had the same answer on this. So another example we have, how about we'll have a coefficient on the term. So for example, we have here 2a plus b raised to 4, for example. So this will become 2a raised to 4 b 0 plus, since we have the plus here, 2a 3 b 1 plus 2a squared b squared 2a b cube plus 2a0 b raised to 4. And we'll look on the triangle. So we have 1, 4, 6, 4, 1. So we have 1, 4, 6, 4, and 1. So 1 times 2 will be 2a raised to 4 times 1 because of this, plus 4 times 2 will be 8, a cube b, plus 6 times 2 is 12, a squared b squared, plus 4 times 2 is 8, a b cube, plus 1 times 2 is 2 times 1, be 2b raised to 4. So that's it. That's how we will get our expansion on the binomials.